We do have a general Q&A session that we'll continue with, so I'll ask our other two speakers to come up to the stage. I also want to welcome Professor Philip Taylor, who's a distinguished university professor and Perkins Professor of Physics at Case Western Reserve University. His research is in soft condensed matter. He's looked at how energy is stored in polymer dielectrics and understanding how polymers used in fuel cells combine hydrogen and oxygen, produce electrical energy. An interesting fact about Dr. Taylor is that he has 6 physical phenomena in science named after him. He also has helped the American Physical Society's draft the statement on climate change. And I will say, being a fellow Cleveland Heightser, he has a personal commitment to living an environmentally sustainable life. Rumor has it he was the first person in Ohio to own a Toyota Prius and install solar panels on his roof. So welcome Dr. Taylor to give us a summary and continue with some Q&A.
Well, we came here to hear answers to a whole bunch of questions about global climate change. You know, what is it? Who's doing it? Is it Mother Nature or is it us? Should we worry? How do we calculate these effects in detail? How confident are we in the models? What are some specific examples of the damage we're doing? Well, we've had some very full answers to all these questions. Michael Mann gave us a broad general introduction to the basic science, and we learned what is the greenhouse effect. We learned that it is without doubt we who are responsible for global warming. That's me and you. We learned that sadly there are deniers of this settled science. And we learned that we may be facing tipping points from which there is no turning back. We learnt that geoengineering solutions have been proposed, but are fraught with hazards. And finally, we learnt that the scale of the problem is just huge, and heroic efforts are needed. Not just personal decisions, but policy decisions are needed. And for some specific examples, we turn to Steve Palumbi. And he showed us how important the oceans are and how much damage we're doing to them. Sea levels are rising and rising too fast for nature to adapt. And he pointed out how global warming is not the only consequence of increased carbon dioxide in the atmosphere, but ocean acidification is a secondary disaster of frightening proportions. Warm oceans hinder photosynthesis, and some organisms, well, there was a note of optimism, some may survive a little better than others, but some are having a bit of a problem. Then finally, we heard from Ram Ramaswamy. And some of us might have been wondering how it was possible to model such a complex entity as the atmosphere, with all its eddies and currents and clouds and dust and polluting gases. Well, I guess a tough job, but it can be done. And we learned that oceans hold most of the stored heat, and so that's something to factor in at the start. And we learned about the importance of aerosols and some of the difficulty of computing them. And again, a slightly encouraging note, not among the gloom and doom, that the accuracy of predictions is rapidly improving, not just with the size of computers, but with our understanding of the processes behind these. Well, we'll close with just a few more questions then for our panel of speakers, and I'll start it off by asking the same question to each of you. If a young person interested in a career in climate science asked you, what are the big exciting challenges still facing you? What would you say? Steve, would you like to start?
Sure, you know, everybody wants to be a marine biologist, right, when they're growing up. And some of us get to I think that the answer here is that the ocean and the world we live in is an enormously variable place in time and space, and organisms have adapted to that variation in time and space for millions of years. And now we're doing this enormously fast experiment in changing that. And I do think that one of the real questions in marine biology and evolutionary biology and ecology is, what is the capacity of our current world to react, adapt, respond to that? And are there things we could do to help that? Are there places we need to put that more attention than others? But really look at our world as a living thing that is in some senses built to react and respond. Understand how much of what we're doing is going to exceed that capacity.
Thank you. Mike?
Ram emphasized the importance of clouds, and I too would sort of point to clouds as an area where there's still substantial uncertainty in terms of their impact on climate change, and the implications are quite broad. For example, the so-called climate sensitivity. How much warming do we get for a doubling of CO2 concentrations? As we've already heard, there are these important feedbacks. One of them is the water vapor feedback. You warm the surface of the planet, you put more moisture into the atmosphere, and water vapor is a very potent greenhouse gas, so you further increase the greenhouse effect. We call that a positive feedback. Well, clouds are probably the one feedback of the principal feedbacks in the climate system where I think Ram would probably agree with me. We don't actually know with certainty the sign of this feedback. And if you had asked us 10 years ago, we probably would have said that we were fairly confident that clouds were a negative net feedback, but there's been quite a bit of work in recent years suggesting that that may not be the case. And it turns out that this is a consequence of a cancellation between two opposing effects. More low clouds tends to cool the planet. It's like painting the planet white. It increases the reflectivity of the planet, and so it's a cooling effect. But high clouds can actually effectively increase the greenhouse effect. And so you need to know not only will there be more clouds or less clouds, but what kind of clouds will there be? And no climate model, including the highest resolution climate models that any of us work with, actually resolve a cloud. So you have to make certain physical assumptions about cloud properties. And there's enough uncertainty in those assumptions that gets at some very basic questions about cloud physics. The bottom line of that being that there is some basic fundamental physics, cloud physics, that still needs to be worked out before we can have the level of confidence we would like on the net impacts of clouds. Now, as go clouds goes the behavior of El Nino, because it turns out that one of the problems in getting El Nino to behave right in a climate model is that the intertropical convergence zone tends to get split. In the real world, there's one dominant convergence zone where you have rising motion and thunderstorms, what we think of as the shifting band of rainfall with the seasons in the tropics. The models, it tends to get split, and part of why that happens has to do with the treatment of marine stratocumulus clouds, and we don't think we're getting those quite right now. So it impacts the sensitivity of the climate system, it impacts things like El Nino, and as goes El Nino, if we want to have confident regional climate change projections for North America, El Nino is such a dominant impact year to year in rainfall patterns and temperature patterns that if you don't know what's going to happen to El Nino, it's very hard to make meaningful regional climate change projections, the sorts of projections that stakeholders need if we're going to engage in adaptive measures to deal with what's coming. So I've looked at clouds from both sides now, and I'm convinced that they remain one of the most important uncertainties.
Yeah, okay, I hope you're not scooped, Ram, by all that.
Yeah, I know. I have to think of something else. I absolutely agree with that, though. I think those are really the central sensitivity points. I would like to pick on another one, which is, if I were kind of thinking about what could form my bread and butter for the next 20 years, I would sort of get at the circulation aspects. because, I mean, the surface temperature, et cetera, is a manifestation of changes in circulation. One of the things that we expect on actually even very firm theoretical grounds is the warming is going to cause changes in meridional gradients of temperature between the equator and the poles. How does it change the atmospheric circulation is a very important point because it may be irreversible. Once you sort of get that locked in, it might affect not just the tropical belt, it may affect the mid-latitudes and even the Arctic. So how to make that connection? I mean, that's a field in its infancy now because the models cannot really get at those questions in a decent way. But I think that's going to be very important. And that's in the atmosphere. Then the oceans, you have the Atlantic meridional circulation. Mike knows a lot about that. What's going to happen to that? I mean, are we kind of on the right path in terms of understanding it? So I think those are all linked to the issues of convection, clouds, but they are something that I think are indicative of a larger circulation change that we have to know about. And I was referring to Northern Hemisphere here, but Southern Hemisphere too can undergo shifts because as the oceans warm up in the Southern Hemisphere, there could be some changes there. So that I would point to are very exciting areas to work in, going beyond just surface warming.
Can I add one more? Ice physics, the physics of ice sheets and ice sheet dynamics, because as goes the physics of ice sheets goes global sea level rise. And as I mentioned in my presentation, just over the past few years, there has been enough of a development in our understanding of some of the more subtle feedback mechanisms involved in the decay of ice sheets that it's literally doubled our estimate of the amount of sea level rise that we could see by the end of this century. And that has huge ramifications for vulnerability and for adaptation when it comes to climate change.
Well, it's a very interesting problem. So you guys better get off to college fast and get working on these. So I have some problems addressed to individual speakers. And for Steve, I will ask this one. You specialize in salt water, of course, but here we have fresh water. And do you foresee any issues with the large bodies of fresh water as a result of climate change?
Sure. The Great Lakes, of course, are some of the biggest bodies of freshwater in the world, and they have a lot of properties like oceans and waves and storm effects. I did look up whether you guys had king tides. And you do, but they're only this big. So you're free, not that. But one of the things that goes on in the oceans is that ocean species range over thousands of miles, and if the climate changes, then say fish stocks will move north, and fishermen can go north. I don't know where your fish are going to go. If they have to go north, they can't get out of this lake. So what happens to your walleye? What happens to your other fish as the climate warms? There's reports that I've heard in the Great Lakes of massive algal blooms that are caused by a combination probably of extra nutrients and then temperature as well. So just because it's not the ocean doesn't mean any of these same things don't actually play out. It's pretty similar in terrestrial environments as well, the same kinds of issues. It's too warm sometimes of year. You were talking about the advancing seasons. The plants know that the seasons are advancing. The animals know that they're advancing because some of their breeding cycles, their flowering cycles are changing, and some of the interactions between plants and animals are getting altered. So flowering cycles and insect and bird pollinators are getting out of whack. So this happens in the middle of continents. It happens in lakes. It happens in rivers as well. I guess I would just say that the organisms that live in these places are pretty well tuned to their environments. And as their environments change rapidly, no matter where they're living, they have to adjust. They have to change. And that's where we worry about, are they being exceeded?
Oh, thank you. for Mike. There are a number of questions that came in from the audience related to taxes, fees, incentives, laws, and so on. And for instance, this one says, is the citizen climate lobby carbon fee and dividend plan a good market-based plan to reduce carbon emissions?
Thanks. I never seem to get out of one of these events without getting at least one question dealing with Citizens Climate Lobby. You guys are legion. There are a lot of folks out there doing a lot of good work for that organization. And yes, they have a very specific mechanism in mind. It's a revenue-neutral carbon tax, and that is appealing to a broad swath of our ideological spectrum, potentially, because the idea here, and this is also similar to what is articulated by Bob Inglis. I mentioned Bob Inglis, a conservative South Carolina congressman who was primaried out of his congressional seat because despite his nearly perfect lifetime conservative voting record, I think he had a 97% conservative voting record, but he did speak out about climate change, and that angered some of the major funders in the party, and he was primaried out of his seat. And now he travels around the country talking to conservative audiences and arguing the case for a revenue-neutral carbon tax, similar to what CCL argues for. And the idea here is that, as Bob would say, we should tax those things we want less of and lower taxes on those things we want more of. And in his view, he thinks income taxes should be lower. And so the idea is we'll institute a carbon tax because we want less carbon in the atmosphere, but to offset that, we will lower income tax so that it is in the aggregate revenue neutral. There has been no net increase in taxation on the American people, and that's appealing to people whose ideological principles are against increasing taxes. There is a rumor that Grover Norquist, the sort of anti-tax maven in the conservative world, was at least briefly in support of a revenue-neutral carbon tax. I think he was asked by a journalist, could you support a revenue-neutral carbon tax? And he said, yeah, we could consider something like that. Then I think he got a phone call from somebody in Kansas, and 24 hours later, he had in fact shifted his position on that and had recanted. But at least for a moment, even Grover Norquist, the anti-tax crusader, was in support of a revenue-neutral carbon tax, which suggests that might be an avenue, if we're looking for some sort of bipartisan vehicle for acting on climate and imposing a price on carbon, maybe something of that sort could get enough support within our Congress, especially depending on what our Congress looks like after this next midterm election. Perhaps something like that could get through Congress.
Very good. Ram, there are a number of questions relating to the difficulty of doing climate modeling and the uncertainties. The idea that there's chaos and a butterfly in Argentina can change the way whether we have a tornado or not, or something like that. So this general family of questions was just how do you deal with these uncertainties?
So the uncertainties you can categorize in terms of basic physics uncertainties. So clouds, for example, would come under that. Emissions, particularly of short-lived species, which is not necessarily in the context of just a model, because it goes back to people who actually do these emission quantification, which is really a separate community, totally. But in terms of, not the greenhouse gases, because those are pretty well known, but the short-lived species like aerosols, because they are so regional, how well do we understand those emissions? So there are uncertainties there. One central uncertainty there is, are they going to come out of the atmosphere very soon? Which has been sort of the assumption in scenario building, that the aerosols are going to come out of the atmosphere because countries are worried about air quality, health, and these are easy to deal with. So all the countries would be in favor of removing them. But that's one uncertainty as to when is it that they're going to be removed. But I think the more broader uncertainty is then the response of the climate system and whatever parameter you're looking at. How do you constrain uncertainties? And one of the biggest factors in them is what in the climate field one calls climate sensitivity. And basically sensitivity is just, if you will, it's just a number in the numerator, degrees temperature change or degrees of whatever change you want, divided by the forcing, in some units. And what is that? Is it very high or is it very low? And right now, some of the uncertainties that we've been talking about, for example, clouds, aerosols, leave aside this a little bit of a nagging question. Is the climate sensitivity that we're thinking of too low? Well, if it's too low, on the low side, there's a range. Typically it's 1.5 to 4.5 degrees centigrade for a doubling of carbon dioxide. If it's closer to, actually it's 2 to 4.5. If it's 2, well, maybe we can buy ourselves some time to deal with the problem. But on the other hand, it could be high. It all depends upon this, silly little thing called aerosols, which we don't understand enough about. So those are uncertainties, I think, that plague not just temperature, but really every other parameter that we would like to get a constraint on. And there are analyses of various sorts being brought into that, not just climate models, but also diagnostic analyses. And from paleo studies in the past, was the Earth this sensitive? And so that's, to me, would be the, it does sort of have a feed-in from lots of other parameters, but that is the one thing that we really have to get down on and reduce the uncertainty if we can. Because, for example, policymakers, kind of for them, that is kind of very fundamental information.
Very good, thank you. And now some general questions. This first one is that 97% of climate scientists are in agreement. And how do you account for the fact that in the general population, that number is not 97%?
I'd be happy to field that question. There has been a concerted campaign to confuse the public and policymakers about the underlying science, and it's not really a mystery. In most of the countries of the world, you don't see that discrepancy. You see an alignment between sort of the scientific consensus and the public consensus. Interestingly enough, it seems to be only in those countries that have an entrenched fossil fuel industry where you do see that discrepancy. And it's not a mystery. Fossil fuel interests in the United States and similar things have happened in Australia, the UK to some extent, and now Canada, have spent tens of millions of dollars in a massive public relations campaign intended to sow doubt and confusion in the public mindset about the underlying science. And this was betrayed, again, in that Luntz memo that I mentioned back in 2002, where there was this internal memo from Frank Luntz, Republican pollster, advising basically the fossil fuel industry and the politicians doing their bidding that, first of all, they needed to manipulate the language to emphasize uncertainty and doubt, and that they needed to fund think tanks, and they needed to, find advocates with impressive credentials who would basically serve as talking heads, as basically advocates for their cause, attacking the underlying science, calling into question the veracity of climate science. And it's actually a playbook that we saw first deployed in tobacco. The tobacco industry spent millions of dollars to sow doubt and confusion about the fundamental science that their own internal research actually had established. In settling a lawsuit with a number of attorneys generals years later, they were forced to turn over the internal documents, and one of those documents actually had the phrase, "Doubt is our product." This was an internal tobacco document, and what they were saying was, as long as they could manufacture doubt in the public mindset and to create and to to cultivate politicians who would be willing to sort of do their bidding as well, they could continue to make massive profits marketing their product. That playbook was appropriated by the fossil fuel industry, and some of the very same players, some of the same scientists with impressive credentials who were paid millions of dollars to act as spokespeople for the tobacco industry, attacking the science linking tobacco to human health, today are getting paid by the fossil fuel industry to attack the science linking fossil fuels and climate change. It's an old tried and true strategy, and unfortunately, it's worked. It has bought them decades of time. It has cost us decades of time. If we had acted on this problem when there was indeed a scientific consensus decades ago, we would be dealing with far less costs than we are now incurring because of this delay, which we can thank fossil fuel interests for.
Would anybody like to add to that?
No, I think Mike expressed it very well. This is a tough one, but I think it might be useful to maybe think of some of the some examples from earlier decades on environmental problems. I think of the acid rain problem and the Clean Air Act. It was a different time politically, of course, but there was still initially a lot of opposition to reducing emissions, and then I think there were taxes if the pollution crossed state boundaries. But to me, the wonderful thing was that everything came together in the end. I mean, there was actually an acceptance of the problem and an agreement to a solution. I think important thing there was that a lot of states agreed to that, particularly I think states in the Midwest and the Northeast agreed to the solution, but also private sector came to the table. Another example I think of is the ozone problem, the Montreal Protocol. Now again, it's a different category of problem because it didn't involve that many countries, it didn't involve that many players, but yet that problem was, at least politically, effectively solved through the protocol and subsequent amendments. And again, private sector was at the table. So I just wonder, I just think that till you get the economic sectors of the country onto the table, as scientists, I think we can keep on, giving the right solutions and the accurate answers and so on. But in the end, you're going to require something other than scientists to be able to completely solve this problem, completely convince the public. But I think that point may be coming because if we are seeing extremes which affect people's lives coming into sync with what is expected from theoretical knowledge and numerical knowledge, then actually there may be a groundswell of movement in the direction of this. It may be that it's just waiting for a threshold to be crossed.
I follow that up because I think that's exactly the right way to think about it too. Is tobacco smoking is a good one. There's this disinformation campaign, but then there was a tipping point where people decided that it was pretty bad. And the evidence was there all along, but the tipping point of people's opinion about smoking was really decades after the science was really there. And it was that tipping point among people that really pushed for things like laws against smoking in restaurants and bars and now in public. And none of you have lit up here in the audience, right? What would happen if one of you did? It would be unthinkable, but not 20 years ago. So it's that tipping point in public discourse that I think we're actually almost there. And people wonder about what can I do about climate change. One of the things is to become informed about it, like from these gentlemen, and then talk about it. Talk about it with your friends and family. And when someone says, oh, climate change can't be true because it's a cold winter, say, what? That doesn't make any sense at all. It's that kind of discourse of being informed and being willing in a polite and friendly, but consistent way of saying, this is important. And when people do that, it affects the people around them. And that changes the tone of the conversation in a way that creates a lot of change. Science is done. It's really how we think about it. I'm looking forward to that tipping point.
A quick follow-up to that. It would be remiss of us to not point out that there was a tipping point in the public consciousness back in the late 1960s, early 1970s over environmental pollution. And there was a single galvanizing event. Next year will mark the 50th anniversary of that event when the Cuyahoga River caught on fire. And it captured the public imagination and consciousness, and it led to a Republican president, Richard Nixon, creating the EPA, the passage of the Clean Air Acts and the Clean Water Acts. George H.W. Bush, that administration, created cap and trade, a system for dealing with the acid rain problem. Ronald Reagan signed the Montreal Protocol to deal with chlorofluorocarbons, which were destroying the ozone layer. This was not always a partisan political issue. Environmental preservation using market-driven mechanisms for dealing with environmental problems was actually a conservative solution that was invoked by past Republican presidents. So we are operating in a new realm. The rules have changed, and to some extent, I think it is because polluting interests have a stranglehold on our political system right now that is unlike anything we've seen before, where if you're a Republican and you open your mouth about climate change, you'll get primaried out of your position. The only way to change that is us. We can change that. We're the ones who elect these people. If we don't like the direction that we're going right now, if we don't like the policy of the U.S. Congress when it comes to dealing with climate change, the official policy is to deny that it's even happening right now. I testified in the House Science Committee a year ago to a committee chair, Lamar Smith, who denies that climate change is real. If we think that that's inappropriate, if we think that we should have a science committee that's actually run by somebody who cares about science, if we think that Congress should be listening to scientists when it comes to matters that involve science-informed policy, then we can make our voices heard at the voting booth. And in less than 250 days, we have an opportunity to say that we want to go in a different direction. And so I would encourage people to get out there and vote, and to get everybody they know to vote in this next election, because change can happen very rapidly. Tipping points still do happen. We've seen it on marriage equality. I think we're going through a tipping point right now on guns. And I think we will see a tipping point on climate in the near future, but not without us constantly pushing forward.
And one last comment.
Can I just follow up with some really note of optimism that I know, for example, BP and Exxon are now very worried about sudden climate change affecting their oil rigs in offshore. So they are very interested in knowing about what's going to happen to waves in the ocean because of climate change. So, it's getting personal. That's what I was coming to, that it is getting sort of closer and closer in terms of economic aspects to the private companies. Reinsurance industry is already on board. In fact, they kind of take the climate information and they run their own sort of actuarial calculations on those to set their own rates. They are very much kind of believing that climate is no longer stationary. And then there is a whole slew of people working on private companies, working with the Army Corps of Engineers on coastal inundation problems, because they're worried about the loss of land over time due to erosion. So there's a lot of activity beginning to happen. I think it has to be sustained, and that requires leadership.
Indeed. Well, It's now time to close this very informative afternoon, and I leave you with these thoughts. The Earth is heating up at a horrifying pace. Ice sheets are melting, oceans are warming, and sea levels are rising. Islands are being submerged. Extreme weather events are becoming ever more frequent and devastating. Heat waves with unbearable temperatures are starting to make whole regions uninhabitable. Starving populations will form a refugee crisis, worse than anything we have seen before. The science of climate change is strong and solid, but our political will to combat climate change is weak and fragile. We are grateful to our distinguished speakers for arming us with the perspectives we need in order to become informed citizens, prepared to call for action on this vitally urgent issue. On behalf of the organizers of this event, including Arthur Hoyer, the moving force behind it, I say thank you to our speakers, to our sponsors, and to our audience. We are adjourned.